So let's start from Houdini empty scene, and this time the first thing we want to do is to set up the project both for Houdini and for Unreal. So as usual, let's create a new project. I will choose my path for it. So I will go in there and I will call this project TARS tutorial. Accept, and I also save the scene. Let's call it TARS tutorial 01. Then from the Epic launcher, I want to launch Unreal. I'm currently on the latest version, the 5.7.4, and we want to create a new project. Let's click on new project, and we want to start from the third person template because we are going to use a lot of feature from the standard third person character. So choose this guy, choose your project location, and I will call this project TARS tutorial. Let's click on create and let it boot the project. Give it a couple of minutes to boot the project, and once we have it, we actually can close it. And now we want to create a variable to reference the Unreal project path to assign here in Houdini. So we want to go wherever you saved your project. So in my case is here, TARS tutorial, and we want to target the content folder. So go inside, copy this path, and here on Houdini, we want to go on Edit, Aliases and Variable. And on the Variable tab is where you define the variable like job and IP. We want to create a new variable. We will call it project. And we want to paste the path on the right column. But we want to reverse this slash, at least if you are on Windows. So let's reverse this. Close it. And basically now, if we drop down, I don't know, a file node, and you start to type $UA project, middle click, you can see that the path is correctly binded. And we're done with the project setup. We can delete this geo we created for the path test. Let's create another one. We will call it TARS and dive inside. And let's start with modeling this geometry, which will be actually quite easy. Basically, it's just for identical pieces. And each piece is basically a single cube by 8 in the height. So I want to start with a box. We will model the single section and then replicate it 4 times. For the sides, I know I want a box of 0.225, and same for the z-axis, and it will be 8 times in the height, so 1.8. Basically, this is the size of one single column of TARS. Now I want to add some segmentation to the model, even if we don't actually need for the geometry. If we add some division here, it will allow us to keep track in Copernicus to where to put this grid effect to actually insert this detail through normal maps. So I want to set the division to 5, 5, and 5, not 52. So we do have 4 and 4, as you can see here. We do have 4 division on the sides, and on the height is actually divided in 4, and then we have other splits. So for the division, 5, 5, 5 is good. Then we want to take a couple of polysplit node, and we want to set it to edge loop, and split here with 4 loop. I mean 3 loops, so 4 segment. Then duplicate it, and we want to change the location to here. So we do have something like this. Let me hide the grid. This is the division we want to apply to the normal map, basically. And actually, before doing anything else, I want to create some reference. So create a geonode. Let's call this ref. I just want to draw some arrow. Let's agree that the forward direction will be the positive z. So I will quickly create a grid, something like this. So I want to create something like this, then extrude the top, extrude it again. And by the way, if you don't know how to pull up this radial menu, is with the C key. And finally, I want to fuse this point. Where's the fuse? Without the distance. So basically, I just want some error that reminds me what's the forward direction. So back into the TARS geometry, I want to drop down a UV flatten because we need UV on this guy. So activate the tool, and to split the edge you just need to keep press the shift key as per indication over here, and we want to split the top part and the bottom one, so all the way around, and also on one side, let's say this internal back one. So we do have something like this, and we want to deactivate the enable manual layout, so we end up with something like this. And basically we're done with the UV part. So let's take a group. We can define some bevel. It's optional, but I do like a little bit of bevel. So let's disable the base group. We want to include by edge, and let's say 91 to 89 on the edge part. So this is our bevel. Let's call this bevel. Take a poly bevel node, drop down here, and let's set it to be applied on the bevel group. And let's give it 0.005 with 2 division, something like this. Maybe even less, 4, yeah. And finally a normal, so we can define some normal on the vertices. And that's it. Drop down a null. This is basically the single module. So out TARS module. So to create the other copies, let's drop down a line. This will go in the x-axis, so 1, 0, 0. Template it. And we need 4 copies, so 4 points. And I actually forgot to raise the module on the y, so it will be resting on the origin. So we want to copy the parameter for the y size, paste relative reference here, divided by 2. So it will rest on the 0 y. And we want to take a copy to points. So we want to copy the module on the lines point. So we have 4 copy. The length of the line needs to be 4 times the module, so 0.675, if I recall correctly. Yes, it seems, yeah. And we also want to define some attributes. So let's take a point wrangle on the line, and we want to create a normal attribute. So a 10, and let me enlarge the point wrangle, is equal to set. We want to establish the forward direction, so 0, 0, and 1, because we said positive z will be the forward, and also a up vector, so be at up on the y, so 0, 1, 0. And also we want to center these lines, so copy the length, negative on the x, pass relative reference, divided by 2. I said negative, not 0. So it's centered on the x. And since we're going to build a rig with this thing, we need some naming convention. So on the line, after the and up, let's drop down a name node. We want to define 4 names, one for each point on the line. So the point number 2 will be the left leg 1. And let's create a visualizer on the name, which will be on the points. So name, left leg 1, and let's add other 3. So point number 3 will be left leg 2. Point number 1 will be right leg 1. And point number 0 will be the right leg 2. Let's hide the point number. So we have these 4 names. And this will be carried over on the points. And on the copy to points, don't forget to pack and instance these guys. Now, we will export everything as FBX, not with Houdini engine this time. And this, of course, will be a single geometry, but we need 2 materials on it. One for the central part and one for the side part. As you can see, it has different texture. So after the copy to points, first let's promote the name attribute. I know that later on I will need it on the primitive, so I want to promote the name from point to primitive. And then I want to split the geometry, so we can define two groups that will be used as two material slots in a real. So we want to split the 1 and 2 point. So we are taking apart the central one. Take a group node, and actually first we need to unpack the geometry. So this will be for the left side. And in here we want to transfer the name attribute. This will be fed into a group, and this will be the center one. After the group, let's take also a UV layout, so we will also differentiate the two legs. They will we won't end up with the same noise pattern on it. And whoops. And now let's duplicate all of it. We will plug it on the right side of the split, and this will be the sides group. Also for the UV layout, let me hide the name. I want to set the island padding to 0. I don't want these gaps between the geometry. So same for this other guy, 0. And I believe everything else is good as it is, so we can merge back these guys. This will be basically the input for the FBX rope, but also we want to create two nulls to use in Copernicus. We will create two copnet, one for the side and one for the center. So this will be out center for cop. And for this one also, let's plug an exploded view, so it will be more easy to spot any problem on the texture while working. And duplicate this null. This will be on the right one, and it will be called outside for cop. So this will be the side for texturing. Then for the geometry, we actually want to pack it back. So drop down a pack node. And here we want to transfer actually everything. So drop down a wildcard, and also here, because we need both the groups back. And we want to pack by attribute name. So we are back with 4 packed geometry. And we don't want to generate packed fragments. We just need packed geometry. And so this will be the out geo. Actually, we will plug another node here to bind the geometry to the skeleton, but we still need to create the skeleton. So now we are going to create 4 animations for the rig, 3 for the movement and 1 for the idle. I mean, the idle is not really necessary, because when a robot is standing still, it's plausible that it's standing perfectly still, but at least we will have some way to know that it's working even when it's not moving in a real. So beside the idle, we will have these 3 movement animation, and as you can see, we have a walk, let's say a jog and a run. The run and the jog are rotating on the middle of one column, but the walk animation rotates on the upper side, let's say 3/4 of it. Now, for some advanced rig, I'm pretty sure there's many ways to define a switch on the pivot of rotation, but in our case, we don't need something that complicated. We just need, let's say, a point in the middle, one on the other rotation point, and we will just need to bind the entire column to the last point. So basically, when we will rotate the center part, it will rotate everything according to the center pivot, and when we will rotate the upper part, it will rotate on the other pivot. I'm sure it will make more sense when we will actually create it. So we want to create another line. This will be the skeleton for a single leg. And let's template the module, and let's see. We want this to be long as the upper joint for the rotation. So in this case, it should be 1.35. So basically this is the rotation pivot for the walk animation, and then we need another point in the middle, so basically here. So we just want to increase the points of the line to 3, and let's see where it is. It is here, so we need to translate it a little bit upper. Let's take a transform node, and it's point number 1, so group 1, group type points. And let's see, we need to raise it of 0.225. So something like this. I don't need a line to be the whole length of the model because we will bind all the geometry of a single leg to this point, basically. And also we will merge the base point all together because for the skeleton hierarchy, we need some center of geometry. So we want to take another copy to points, and this time we don't want to pack an instance, these guys. So we do have, the reverse way. If you want to quickly reverse the input of a node, just press Shift R and it will switch the input. So we do have something like this, but if we display the name attribute, now the name for the points, it's all the same. It was fine on the geometry, not for the skeleton. So let's duplicate this name node, and basically we want to rename the top points. The central one are fine as it is. So let's plug this name node. And here, let's see, let me hide the name. This is 0.8 or 3, should be 8. So the 8 will be L leg 1 top, and display the name back. Yeah, it's working. So the 11 will be 2 top, and same for the right side. So the point number 5 will be 1 top, and point number 2 will be 2 top. So if we display the name, now we have the original name on the central point, the new one on the top part, and we are going to merge the bottom one right away. So let's take a fuse node, plug it after the name, and here we want to select only the bottom points without snap distance, so they will fuse all together. And now let's take a final name node, so we can rename only the bottom point, which is the point number 0, and we will call it cog. So now we are good with the name for our skeleton. So finally, let's take a rig doctor after the name, and in here we don't want to initialize or sanitize name because we established the name and we're fine with our naming, but we want to initialize the transform and also convert instance attribute. This will basically create the transform matrix using the up and normal vector we created early in the chain. So basically, if we take not a rig doctor, a rig pose here, what we have is basically a cog, which will move the entire geometry. And then we have the joint for the leg at the middle rotation, which rotates the other one. Or we will use this other one to rotate for the walking animation, which right now is not doing anything, but it will rotate the geometry. And it won't cause issue because we won't rotate both of the points. We will use this one for rotating the run and the jog, and this one for the walk. So we are fine with this kind of setup. So let's take another null after the rig doctor. This will be out skeleton. Let's place it beside the geometry. And now we need to take a capture pack geometry node after the pack for the geometry, and we want to plug the read doctor on the right side. So basically here we can define what geometry is captured by which bond. And we want to do it manually because it's just 4 captures. So 1, 2, 3, and 4. And basically we just need to say which package geometry is captured by which joint. So the joint in here is at name is equal left leg 1 top. And I believe the geometry is the number 0. Let me check. Yeah, number 0. So 0, then 1 is the, let me copy this line, the left leg 2. And then we have 2 and 3 for the right leg 1 top and right leg 2 top. So basically here, if we display the spreadsheet, we should have a bone capture that say which bone is controlling this part of the geometry. And I will actually split the video right here because we are done with the geometry and the skeleton. So in the next chapter, we're going to actually create the rig and animate it with Apex.